We cannot see you, Josh, by the way.
Okay.
I think by default, Zoom start with the camera off.
Sorry, it's before my coffee time. Let's see here.
All right, so I think
Now
that we are live.
Hi. I have a bit of a cold.
Okay, so are we all ready?
Always ready. Okay, let me see here.
Okay, so we are here in this talk about reactive programming with Josh Long in this meetup, virtual meetup. Sergey and I, we are going to be monitoring the comments in YouTube. So if you want to ask any question to Josh, we'll be paying attention and we'll make the questions. You may ask in Spanish if you want, because I'm seeing that some people are already writing in Spanish. Josh, do you prefer that we wait until the very end to make you the questions, or do you prefer that we stop you and make the questions live?
Can we? How long do we have to talk?
About an hour.
Oh, only an hour, huh? Okay. Yeah, let's just wait till the end. We don't have a lot of time, right? So let's just try and...
Okay, you may ask the question at any time, and Sergey and I will be writing them down, and then we'll ask them to Josh. And if you want to ask in Spanish, it's fine. We'll translate them for you. And if the people in the chat want to say where they are coming from, it can be interesting because we have some registrations from different countries. So you want to say which city and country are you on, you may say that. Josh, I guess everybody's life has changed a lot in these COVID times, but I guess your life changed more than usual because you used to be in 4 different countries every week or so. And now I guess you are stuck in San Francisco, right?
Yeah, it's you know, and I miss Spain, of course. But yeah, I'm stuck in San Francisco, and I have asthma, so for me the virus is even scarier than a lot of people, you know. So
yes, you better take care.
Yeah.
Lovely. So let's get started. I think that we can get started. And Josh, this talk is called the same way as your book.
Yes. Yeah, exactly. Same as my book.
So what can we expect today?
Well, so we've only got an hour. That's the interesting problem that we have. What do we got? I think we're just gonna talk about all things reactive, right? We're gonna talk about what it means to build applications that take advantage of reactive programming, particularly in the context of services and systems, and so on.
Great. Lovely. So if you're ready, just take it away. You can share your screen, and we'll be just monitoring the chat. So any questions, just put them on the chat, and we'll just forward them to you at the very end of the talk. Okay?
Okay. Thanks.
So I'll give it to you.
All righty. Okay. Good morning, everybody. Hi. I appreciate you being here. Obviously, as we just talked about, it's a weird year. I am so glad we get to talk at least this one last time. Before I forget, this first of all, I want to say, you know, what do I want to say? I want to say, first of all, it's Thanksgiving week rather, here in the United States, and during that week, we're supposed to be thankful, and I'm really thankful this year that I'm still alive, but I'm also very thankful in general for communities like yourself. So thank you for that. And then second of all, Merry Christmas if you celebrate. That's coming soon. I don't want to forget. And then finally, you know, it's really good to see you all. Me alegra verles. You know, I'm just happy to be here and to see you all and so on. So a little bit about myself. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate. I'm a Kotlin Google developer expert and a Java champion. And I am at your service. So if you have questions, if you have comments, if you have feedback, whatever, you can send them to me at Twitter at StarbucksMan or on email, josh@joshlong.com. And the code that we're going to look at there is on github.com. So github.com, Josh Long, reactive-revolution. I have done training videos. I have a book called Cloud Native Java that I wrote 3 years ago. I have a podcast that I do every Friday. I have a blog I do every Tuesday. It's called This Week in Spring. every Wednesday there's a screencast. Sometimes I don't do this because there's breaks between the seasons. And I have a new book that I just published that's out now. You can buy it. It's done. It's called Reactive Spring. And this book is all about how to build applications that take advantage of reactive programming. Now, in order to care about reactive programming, we need to consider why we care about reactive programming, what has driven us to this. And there are three main use cases that reactive programming addresses. Hold on, the dog is trying to enter. There are three main use cases that reactive programming addresses. First, resource efficiency. And I'm going to talk about that in a second. Basically, it's the idea that you get better reuse of threads and resources and memory in the Java application through a smart scheduler and, of course, more efficient use of input and output. That's the first thing you get, is resource efficiency, right? The second thing you get is a consistent API. So you get one API that you can use to describe all sorts of different sources of data, right? And so it doesn't matter if the data is coming from Kafka or from a REST endpoint or WebSockets or a database or whatever. It's still just one kind of thing. It's called a reactive stream. It's an implementation of a particular Java type called publisher. And then finally, the third thing that you get when you use reactive APIs is you get an API that gives you tools or operators that you can use to make safe network calls, to make it easier to build reliable services across the network. Now, let's talk about that first point a little bit here. That first point is fairly important. The idea is that reactive programming is a programming model that gives you a chance to write code that tells the runtime when something is blocking a thread, right? So you have a chance to, with the runtime, give information to the runtime about how busy something is. And if you're not using a thread, you have a chance to jump off of that thread and return the thread to the thread pool. The reason we care about this is because we want something else in the system to be able to reuse that thread. And the reason we care about doing that is because threads today, in 2020, are very expensive, right? Project Loom will address some of that, right? Project Loom will make it so that you can create lots and lots and lots of virtual threads or green threads, right? Or lightweight threads. The names change every now and then, but it's the same idea. So when you see Project Loom lightweight or virtual or green, it's all the same thing, right? This is a very exciting opportunity. And what this means is that we'll be able to create many, many, many small threads. And even better, we're told, we're going to be able to use input stream and output stream. And instead of blocking, as they do right now, those objects will relinquish the thread. They'll return those threads back to the thread pool whenever possible. So right now, if you say Java IO input stream .read and you wait and you ask for the next byte, you must sit there and wait. You must wait, and the next byte will come when it comes. But you cannot jump off of the thread that you're using. That client thread that you're sitting on, waiting for that data, that's stuck. You can't do anything until the next byte arrives, right? Hopefully soon that problem will go away. The problem is that even here, it's useful to consider an asynchronous, event-driven style of programming instead of using input streams, right? Even with Project Loom, it's advisable to not use input streams if you can, because input streams and output streams take up a lot of memory and RAM. They're heavy weight, and so you can get some better performance by using asynchronous I/O. The reason that we care about the heaviness of these objects is because that'll be a saturation point, right? Imagine you can create tens of thousands of lightweight threads, no problem, or hundreds of thousands maybe, but you can't create that many input streams and output streams. That means you can't do I/O for each thread, right? That means that will saturate before you get the chance to scale. So even there, it's recommended. It seems logical, at least to me. I'm not sure what the Java team is recommending, but it seems logical that you'd want to take advantage of much more efficient asynchronous I/O. So hopefully, part of this problem, part of the first point, will go away. Hopefully soon, Loom will make some of that less of an issue. But we still have these other two concerns, right? We still have the question about how do we have a consistent API, and we have a question about how do we build more reliable services. Reactive APIs give us all of this. Let's go ahead. I haven't been sick since March. I have, because I don't go outside, and now I have a cold somehow. Anyway, but I'm sneezing, so it's not coronavirus, you know. So reactive APIs give us a way to address these three concerns. That's very useful, right? It gives us a way to build better software that's more reliable in the context of production. And that's also what I care about. I care about production. I care about software that does the right thing, even in the face of distribution, even with service distribution. I want my software to do the right thing. So we're going to see all of that in action today, my friends. We're going to write some software, as always, by going to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. We should all go to production as early and often as possible. But if you haven't been to production, you can begin your journey here at start.spring.io. And there's a lot of really nice things here on start.spring.io. First of all, the version of Maven, or the build tool that you want to use, you can specify here. So Maven, Gradle, etc. And then the choice of the language you can specify here. I'm satisfied with both of those. And then we have the choice of the version of Spring Boot. And friends, there's a lot of features here in Spring Boot 2.3 and 2.4 that I recommend that you check out. This is a whole different talk. If we had an extra hour, I could show you a lot more of those. But there are amazing features. There's well, first of all, Spring Boot 2.4 works very nicely with our Spring GraalVM project. So Spring GraalVM Experimental is a project that's not yet GA, but this project gives you the ability to take Spring Boot applications and turn them into GraalVM native images. And the idea behind GraalVM is that it was it is a C1 just-in-time hotspot replacement, basically. It's a just-in-time compiler replacement. So they wrote it in order to replace hotspot, and they wrote it with Java instead of, it's mostly Java with a very little bit of C++. So it's much easier to maintain. This C1 replacement is already awesome, even by itself. Just using that, you get a lot of benefits for a lot of applications. But that was not enough for them. They wanted to do even more magic. So they built something that takes the code, and instead of compiling just a little bit to native code, as you do with hotspot, they wanted to compile the whole application, up front before the running of the application. And so this is called ahead of time compilation. And there's a tool that you can use called native image. And it's awesome. The resulting binaries are really fast, right? Really, really fast. And they also take less memory, right? So here we go. So I've got a application here. This is on my GitHub. So github.com, Josh Long, etc. Right? Not there. WebFlux actuator GraalVM. Right? So that's my the GitHub repository for this. Okay. So there you go. You can find this code here. You can run it yourself. It's easy. But the result is you can compile your applications and get these incredibly fast binaries. So here is my Java jar, the original jar, the artifact that's built by default using the JVM. This requires you to have a JDK on the local machine. But of course, you can run it, really quickly, java -jar wag. Now keep in mind, this application starts up an embedded database as well. So everything that you need is there, right? Let's see here. Okay, so it's starting up an embedded database, etc. Okay, good. Now the native image support looks like this. That was too slow. Going faster. There we go. So that application is native, right? It's a binary that starts up in, there you go, 0.13 seconds. So a tenth of a second or so, basically. really, really fast. And even more impressive, the application takes very little memory at runtime. So instead of using hundreds of megabytes, it takes tens of megabytes of RAM, which is great, especially in the era of the cloud, right? Cloud computing is what this is really enabling. You can now deploy these applications to your production environment. And in fact, with Spring Boot 2.4, there's a bunch of other features that you can use that make it easier to turn the applications into Docker containers. Actually, this is part of Spring Boot 2.3. So I can say Maven Spring Boot build-image. I have to sneeze. You can say Maven Spring Boot build image, and it'll automatically create a Docker image for you. And that worked in 2.3 as well. That's 2 versions of Spring Boot that support that now. But now, if you configure, you can configure your application to support building native images inside of the Docker image, right? So this is what I had to do. I had to do execution, native image package, and otherwise it's the same. It's just oh, sorry, no, that's the wrong one. Here, this is the one, right? This is optional. You don't need this. So you could just do this. This would be enough. You do configuration, image, BP native image, and this will create a Docker container. It'll run the native image builder inside of there. It'll compile your application, and then deploy that to a container image on your local Docker registry. You can even change the output name of the image, and then you can Docker push that to a Docker Hub or GitHub releases, GitHub containers, or Google Container Registry or whatever, right? Anything you want, right? So the result is that now I have an application, Docker PSI, is it? No, Docker images. There we go. And this is called, oh my goodness. Where do we put it? It's called WAG. Oops. Oh, you could do that. Maven Spring Boot build image. I'll let that run in the background, and that'll build my native image for me. Okay, so that's really powerful. That's all in Spring Boot 2.3 and 4. There's other features that support the movement of your code to the cloud in Spring Boot 2.3 and 2.4. Another thing that's really nice in Spring Boot 2.3 is the ability to have graceful shutdown. So imagine you have a Kubernetes application and the pod gets killed, and you want to make sure that any in-flight requests are finished before the pod is completely destroyed. Well, you can tell Spring Boot to wait like 20 seconds or 30 seconds or whatever, so that you can wait for the response. You can wait for any in-flight transactions to finish before you stop running, right? Before you shut down the JVM. That's very convenient. That's built in now. We also have the support in Spring Boot 2.4 to load a configuration tree. So a config tree is a directory full of configuration that you get normally when you mount a config map as a directory in your application, right? So this is another very, very useful default behavior that you can have now. So you can do configuration from Spring Cloud Config Server for HashiCorp Vault, from a config map, from a directory, from a property file, from local jar class path file, all sorts of different things there. We also have built-in support for liveness and readiness probes as part of the Spring Boot actuator, and so on. So all these features are designed to make moving your applications into production much easier. Now, all that is great, and I recommend you use Spring Boot for that, if not anything else, right? But we're not going to focus on all that. We're going to talk about building applications taking advantage of reactive programming. So what I'm going to do is I'm going to build a service. I'm going to use the reactive web support. I'm going to use Rsoc support. I'm going to use Lombok. I'm going to use R2DBC, which is a reactive relational database connectivity abstraction. I'll use Postgres, which reminds me I need to brew services start Postgres. Okay. There we go. I'm going to use Postgres. I'm going to use maybe the security support. And of course, I'm going to use Lombok. So I'll bring in, do I already have Lombok? I've got Lombok. So Reactive Web, RSocket, Lombok, R2DBC, Postgres, security. And then finally, I have down here, I have some choices that people are confused about. They don't know when and where to choose which. First of all, friends, we have the choice of packaging. Obviously, you should use jar, right? It's 2020. This is a big part of my overarching guiding personal philosophy of make jar, not war. So always choose jar. Then we have a choice of what version of Java we want to use. And it looks like we have 3 choices, my friend, but we don't have 3 choices. We just have 2. There's only 2 real choices. The current long-term supported version of Java, which is Java 11, that's fine. And the current supported version of Java, which will be not supported in another 4 months or something like that, very soon, right? So either one of these is acceptable. I prefer Java 15. It has multi-line strings. There's a lot of great stuff there, but I will accept Java 11. What is a non-choice, my friends, is Java 8. This is a choice that you could make, but that you should not, right? This is a choice that should never, ever be made. It's a non-choice. A non-choice is not just an Indian bread, my friends. It's a choice that you should not, in any circumstance, decide to make. Java 8 is technically inferior in every way. It has less features, less syntax, less performance, less security, less robustness, less everything, right? Less performance, less efficiency. It's the worst in every way, technically. It's also morally the wrong choice. It's morally inferior. How do you think your kids are going to react when they find out that you're using Java 8 in production? I don't think you're going to like that conversation, my friends. The sad look of despair in their little faces as they start to cry when they realize you're still using Java 8. Heartbreaking. Heartbreaking. Don't do it. Be the change that you want to see. Use Java 15. So we'll hit generate, and we're going to open this up in our IDE. Is this done? Almost done. See, this takes a long time. That's why I'm glad I got this in the background there. So I'm going to open this up. Almost. Oh. Yeah, okay, waiting for everything. Okay, almost there. Looks like we're almost there on both sides. Okay. Okay, so we have a brand new application. Let's comment out some of the dependencies that we do not need just yet, okay? So what I'm going to do is I'm going to create an application. Oops, there you go. It's exporting the Docker image now, so it's done the native image. So it's now creating the container, and it's going to export those layers to our Docker registry, and we'll have something soon. There it is. Right? Wait for it to finish. Come on. Okay, well, anyway. There we go. So we can do Docker run. There we go. So there's our native image inside of a Docker container, right? You can see how easy that was. Very, very convenient, right? Now I can just deploy that to Kubernetes, create a deployment, and I'm in production, right? Very, very convenient. So now I have this service. I have to sneeze again. Okay, anyway, I have this service. And I'm going to comment out some of the stuff that we may not use just yet. So let's get rid of that for now. And get rid of the security over here as well for now, just for now. And then I'm going to reinstate. We're going to bring in the other dependencies. We're going to reload the configuration there. And I'm going to build an application that writes data to the database. Okay, so we'll call this a application. We're going to call this a customer service. So I'm going to create an application that reads from my local customers database. Okay, select all from customers. There you go. So I've got some names in the database. I just want to read them. So I'm going to say customer. Okay, and it's going to have a mapping ID and a string. Right, name, string, name. And the goal here is just to have something that makes it easy for me to map, rather, the data in the database to my Java objects. Okay, so I'm just creating a mapping object. And in order to support reading and writing to that database, I'm going to use a reactive repository. So I'm going to use the reactive CRUD repository, managing entities of type customer whose primary key is of type integer. Now, the reactive CRUD repository does the work of publishing data. It does the work of managing the life cycle of data. So let me make this a larger here, 26. There we go. So you can see it has save all, count, delete, etc. All these normal methods. Those are all, I expect, very familiar. What may not be familiar is the parameter types. So you have a parameter, publisher. A publisher is an asynchronous thing. It publishes data asynchronously to a subscriber. When the subscriber first subscribes, it is given a subscription. We will talk about this in a second. When there are new records, they are passed here in the onNext method. When there are errors, those are passed here in the onError method. And finally, when we are done processing the data, the onComplete method is called back. Now, I said that this is very important. The subscription is what the subscriber uses to ask for more or less data. The subscriber can say, I want 10 records, and the publisher will give it no more than 10 records. This ability to ask for more data or to cancel data is very important in building stable, robust, distributed systems. We know that at scale, this is very important, right? We know that it's very important to make sure to slow down the rate of consumption so that a consumer is not overwhelmed. This is why we use message queues logically at the architectural level, at the services level, right? We also understand that this is very important at the smallest network exchange model, right? The smallest network interaction or communication pattern. We talk about messages being communicated over the network. We talk about flow control with TCP and UDP, right? So we know about that as well, right? Very, very important at the small level, very important at the big level. Either way, we need to care about flow control. What happens when one side goes faster than the other? Well, here, we just have this now as part of the top-level API. It's part of the service API itself, right? Okay, so we have these reactive streams types, all three I showed you so far. There's a fourth one called a processor. Now, a processor is just a bridge. It's a source. Whoops, wrong one. Processor, please. It's a bridge. It's a source and a sink, a publisher and a subscriber, a producer and a consumer. And that's it. That's the reactive stream specification. These come from the reactive streams jar, right? This jar contains only 4 interfaces and 1 concrete class. That's it. These 5 types are the reactive stream specification. They're very basic, but they're very useful. They're so basic, in fact, that they're actually part of JDK. So you can see Java util concurrent flow dot processor dot subscription dot subscriber and dot publisher. Right? These are part of the JDK itself. They're foundational. Now, of course, they're a little basic, and so we want some specialized types. We want 2 types. One is a mono. A mono is a reactive stream. It's a publisher that produces 0 or 1 record, at most 1. And then we have a flux. A flux is a publisher that produces 0, 1, 2, 3, 4, whatever. And so flux could be unlimited. It could be a trillion or unlimited data. It could be 1 record. It could be 5. It could be 0, right? So a publisher, they're both publishers, but they have different semantics. And they have lots of operators. See all this code? These are all methods that you can call to compose and work with and filter and flat map and all these different operations on your streams of data. And so taken together, these 2 types, flux, mono, and the reactive streams types are what you're going to deal with most of the time when it comes to reactive APIs. So now I have my HTTP interface. I'm going to build an endpoint to serve up that data. Okay. Oh no, actually, you know what I want to do? I'm going to build an application listener to write some data to the database when the application starts up. So I'm going to write some data to the database. And what I want to do is I want to inject my collaborating object here, my customer repository. And I'm going to write some names to the database. So var names equals flux.just. And I'll put some names. So Sergey, of course, I'm there. Who else is awesome in the Spring community? Of course, Madura. She's like, it's her birthday, by the way. Spring boot committer, Madura Babe. It's her birthday. So if you want to wish her, you know, Feliz cumpleaños today, that's a good thing. Dr. Dave Sire, he had his birthday on Saturday or Friday, I think, right? So 2 birthday people, and they're both amazing, right? Spencer, we've got Violetta, we've got Olga. So, you know, people on the Spring team, right? Spring, and what I'm going to do is I'm going to visit each name, new customer. I'm going to save it like this. And that gives me a stream of customers. And I want to save each one of those to the database. So I'll take each one and map it. I'll say map. And if I do map and call customer repository.save, I have a problem, right? And the problem is that the save method returns a mono. It returns a mono. And so what I have here is a flux of mono. Well, I don't want a flux of mono. See, this is 1, 2 reactive asynchronous streams. So instead, I want to flatten the curve, and I want to flatten my streams. I use flatten map. Okay, so there's my var saved. Okay, there's my reactive stream. Now, I can use them both, this is okay, you know. But I write my code. Usually, I chain these things together like this. So there and there. Okay. Now, I also want to delete everything first. I want to reset the database, right? So I say delete all. And then I say, write this there. And then I say, I want to find all the data. So, and then finally subscribe, right? There you go. So there's my reactive streams. But notice I'm using these operators to make sure that one thing follows the other. Okay, this is very important. In reactive APIs, anything that returns a reactive type like a mono or a flux or a publisher will execute asynchronously, right? It'll happen in a separate thread. So you need to use these operators to guarantee that step 1 happens before step 2. Otherwise, they might happen at the same time because they're not going to run in the same thread. Okay, and finally, if I ran this code right here, just like this, if I ran this code, nothing would happen, right? I need to subscribe. So you say subscribe. This is very important, and you can print out the results here as well. Okay, so there's my reactive stream. Now I'm going to save this data. I'm going to run this program. And let's see what we get. Invalid source release Java 15, huh? What is the deal? Oh, okay. SDK list Java. Okay, run that. Downloads. Sorry, friends. Okay, looks like it's happy again. Let's try this one more time. Oh, loading. Why does it take so long? This is my least favorite part these days. Okay, so it's acting like it's never seen Java 15 before. I don't know why, but that's okay. We'll just use it anyway. There we go. Seems happier. Okay, so restart. Okay, so it's complaining, understandably, that it's not able to connect to a database. So here, I'll go to my property file, and I'll say spring.r2dbc.url, r2dbc Postgres localhost orders, okay? And I'm going to specify a username, orders. I'll specify a password, orders, okay? So I'm going to restart this. And now it should be able to connect to my local database. Let's see what happens. Okay, so there it is. It's up and running. And there's our data. Okay, so we've got our 8 records, right? That's working fine. That works, right? So now I've got data in the database. Let's create an HTTP endpoint. And by the way, now that I've got the data in the database, I'm going to comment this out because I want to leave it there. I need these IDs to remain the same because we'll need that in a second. So for now, I'm going to create a router function, server response, routes, return route build dot, okay, and I'm going to call this customers, new handler function. What I'm doing is I'm handling the response by using this functional reactive API. And in order to produce a response, I need to inject my customer repository. I'm going to say that the data type is of type customer. Okay, so there's this. This, of course, becomes a Lambda, and that becomes a static import, and so on. So very, very convenient, right? So now, if you think about it, really, this is not real code. You don't need that code anymore, right? So there's my application. I've got a functional reactive application that has an HTTP endpoint, and I have a reactive data access layer here, and I have a data model. But of course, in Java 14, there's a feature. There's a feature in Java 14 to allow, it's a preview feature to allow records, Java records. So you could say record foo, and then string name, integer ID, etc. Right? And so that would be much more concise. In Kotlin, of course, you've got data class foo ID int name string, right? And in Scala, you've got case class foo ID int name string. So much easier in every other language to create this than in Java, right? So, but really, this should be a one-liner. So I call that just one line because soon it will be one line. That's 2 lines. That's 1, 2, 3, 4, 5, 6. So that's 8, 9 lines of code to get a reactive HTTP service that talks to a SQL database, etc. Not bad, right? Localhost, customers, etc. There we go. So there's our data. No big deal. Now I want to build another service. So I'm going to go back here and I'm going to call this orders service. I should have called the first one customer service. It does not matter for now. Let's get rid of the security. I don't think we have enough time. And we don't need the reactive web support there. So we'll hit generate. And here, I'm not going to talk to a database. I'm just going to hard code some data so we can see what it looks like, right? Okay. Order service. Now this service, I want to create a new type. In a microservice environment, it's very common to have a secondary type. And so in this case, I'll have another bounded context. And this, actually, it'll be an order ID and it'll be a customer ID, right? Because what you do is you don't have actual foreign keys, but you do have links to other types in the system. So I'll do that here. I'm going to create another type. This is going to be its own type because remember, you could delete your account, but the business still needs to know about which orders have been processed and how much money and so on. So there are 2 different services, 2 different domains, 2 different bounded contexts. There are maybe better examples, but this does work. Okay, so I'm going to create a bootstrapper, void bootstrap fake data. Okay, and all I want to do is create a map of people's orders by the customer ID. Okay, new concurrent hash map. Hello. And so I'm going to say for var customer ID equals, and then what was the customer ID that we had before? The lowest is 157.163. So 157 customer ID is less than less than or equal to 163. Okay, and then for each customer, I'm going to create some fake orders. Okay, orders equals new array list order, and for var order ID equals 1, order ID is less than math.random times whatever 100 order ID plus plus. Okay, and here I'll say orders.add new order customer ID. So it's order ID and then customer ID. Okay, and once I've got this, I can say this.orders.put customer ID order. So there's my little fake database of orders belonging to a different customer. Okay, and that can support now our next endpoint. Now here, I could use HTTP. There's no reason not to, but there's so many different ways for services to communicate one with the other. And so what I want to look at is something called Rsoc. Rsoc is an improvement on top of HTTP. I'm sorry, it improves on HTTP, but it is not HTTP. It is a protocol that was built by the engineers who were at Netflix and who then went to Facebook. And when at Facebook, they had this question about how do they build software that supports different message exchange patterns. It's not just request response. How do you support an endpoint that supports bi-directional communication? How do you support an endpoint that is binary as opposed to HTTP1, which is text? How do you support observability, right? We want something in the message, we want something in the protocol that tells other services how healthy the service is, right? That's built into Rsoc as well. So we want all these things that make it faster, more reliable, more secure, more scalable, and also natively reactive. Sorry, my friends. I know that's gross, and some things should not be open sourced, but I can't help it, So we want a protocol that gives us all of these benefits. And does so in a fashion that's cross-platform. And so there's different options here. We can look at gRPC. gRPC is something from Google, and it requires you to do code generation, and it requires you to use Google protocol buffs for everything. So the payload must be Google protocol buffs. And when it does code generation, the resulting client and service are not reactive, they're asynchronous. You can use a plugin, a compiler plugin from Salesforce. I don't know if you have Salesforce over there. Some countries don't, but they're a pretty big company here in Silicon Valley. I live in San Francisco. In San Francisco, they have a really hideous, really huge building, very ugly, and it's just in my living room over there. I can see it right there. So anyway, they're a nice company. I just don't like the building. They've built a reactor compatible code generator for gRPC. So that's interesting, right? You could check that out. That might be useful. But I like something that doesn't have those limitations. That doesn't support, I want something that supports other payloads, and I want something that supports non-code generation. So Rsoc is very nice. Now, Rsoc was built, like I say, by engineers at Facebook and Netflix. It's an open source protocol, and it's natively aware of back pressure. It's natively aware of flow control, right? So on the wire, when you have data, you can communicate that data from one node to the other, and you can tell the consumer that you can tell the producer rather that you cannot handle any more data, right? This ability to express back pressure is very different than, for example, HTTP. With HTTP, imagine you have a reactive web service, and you have a client, and the client is connected to the reactive web service, and the client disconnects. Well, in this case, the HTTP service can see the disconnect and then apply transitive back pressure. It can apply cancel all the way down to the original source of the data. So it can do this one time, but it can't do it multiple times. There's no way in HTTP to request 10 records and then do something else and then request 10 records an hour later, right? With RSocket, you can do that. You have session resumption. So there's a lot of really nice things about RSocket that make it really fast. And it's also the first project that the Spring team and Facebook and Alibaba and Lightbend, all of us created the Reactive Foundation. And the Reactive Foundation is a brand new foundation dedicated to solving and describing problems and solutions for problems in the reactive space. And the first project that we donated to this new foundation is RSocket, right? So it's got good footing, it's got good foundations, and there's even collaborative work being done with the Spring team and Alibaba and all these other organizations around a broker. So maybe next year when we talk, we'll talk about the broker. The point is, RSocket has many clients in many different languages in Java, JavaScript, C++, C, etc. The Java client is built on Reactor. So it's very easy for us to build something in Spring on top of that because we already have Reactor here. However, the Spring team wasn't happy with that. They wanted it to be even easier. So in Spring Boot 2.0, we have a built-in component model for RSocket. So what I'm going to do is I'm going to create a controller here, class order controller, and I'm going to create an endpoint called orders, publisher of order, get orders. Okay, and this controller, you know, we need to build up that instance, don't we? So here we go. Take that. Good. Right. So there's our controller. Actually, this could just be a constructor. Why not? There we go. And this goes here. Good. So there's our controller. And now I'm going to say for each order, I'm going to say for each destination variable, integer customer ID, customer ID. Okay. So return this dot orders dot get or default customer ID new array list, right? Actually, we can return just an empty one, right? So collections empty list. Good. And then we want this will give us a list of results. But what I want is to send back a reactive stream. So I'll say return flux.from iterable or default. Okay. There we go. There's my reactive stream of results. Orders. Okay. So there's that. Now that's my RSocket controller. I only need to tell Spring to create a server. So I say RSocket server port, and this will be 8888, and then we can restart. So now I have a service. I have an order service and I have a customer service. Let's connect to both of them. So I'm going to go back here and create a client. And here, we don't need Postgres, we don't need RTBC, we just need Lombok and the Reactive Web Support. And by the way, I forgot to remove the database from my order service, didn't I? Look at that. So it's just RSocket, right? There's just nothing there, really. Okay, so we go back here. Generate. UAO client.zip. So this client is going to be an application that talks to our two different services. And here we're going to see where I showed you before is that reactive APIs are not verbose. They give you very resource efficient APIs. So every time there's input and output, we are not sitting on the thread waiting. That means that the thread is free for something else in the system to reuse. The benefit of that is that you get much better scalability. And you get the scalability because now you can handle many more requests with the same threads, with the same resources, with the same amount of memory, right? You can handle many more. That's the goal. I've also showed you that with reactive APIs, it's not a lot of code, right? It's the same amount of code you would write for non-reactive APIs. It's just that now the code is much more resource efficient, much more cost effective. Your data center bill will be much less. And this is a very common thing, by the way. When you log into a data center, it's very common to see that the service is idle, right? The computers are idle because all the threads are parked waiting for something to happen, so they cannot handle any more requests. And yet the CPU says nothing is happening. It's idle, right? What is that? That's a big problem. Reactive APIs solves that for you. So Reactive APIs already are a benefit, and you can see it's not harder it's not harder conceptually to use it. Where I think Reactive APIs really shine, however, is when it comes to service orchestration and composition. So I'm going to do something terrible, something that you should never ever do, ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste some code, and we're going to go to the service here, the customer service. Take all that. There we are. Paste that as well. Good. So there's my two types, okay? I've got my two DTOs here. And what I want to do is I want to build an application that provides a new endpoint that is the result of combining those. So in order to make a reactive non-blocking HTTP client, I will create a web client. Okay, this is a non-blocking HTTP client, and we recommend you use this even if you're not using reactive services, right? Because this is a much better, this is like the REST template, but it's non-blocking. It's much better all around. So even if you're not calling a reactive HTTP endpoint, this is still very recommended, especially in the world of microservices. We have lots of calls. Use this instead, much better, okay? So let's create a application listener, okay? Application ready event. And this, of course, by the way, I forgot, let me, this will start up in some port 8082, okay? And did my other one start up? That's the other thing I don't think we checked. That's 8080 order service. It's our socket. Okay, good. So client. Now, return event. Now, normally, the first problem we'd have is how do we discover the service? Well, of course, you should use a service registry. You should do client-side load balancing. Spring Cloud has a good abstraction called the discovery client. You can use that to talk to the Kubernetes API, Cloud Foundry, HashiCorp Console, etcd, Netflix Eureka, Apache Zookeeper. All of these can be used as a service registry from this API. And so you can use that. You can even plug in a little filter here, like this filter. I don't have the class on the class path here, but you can load. There's a load balancer, exchange, filter function, something like that, and you can use that to do client-side load balancing. But I don't have a service registry set up here, so we'll just use the regular host and port. But that's the first thing you want to care about is that. Now that we have this, let's inject this here, and I want to make a network call and get the data, right? So actually, better yet, maybe I'll create a service, or a client for the service. So I'll create an endpoint here to give me all the orders for integer customer ID. Okay, and I'll have another endpoint here to get the customer. Okay, at component. And return flux.empty. So I'm returning some sample data. Let's build this client out together. We're going to use the reactive non-blocking web client there to make this network call. I'm going to synthesize the constructor here, required args constructor. And now I want to make a call to the customer service. Well, that's using HTTP. So here we go, .get.uri, HTTP, localhost 8080/customers. And when the data comes back, I want to take the JSON data and convert it into a stream of customer objects. Now, this will work, right? I've already got a reactive stream of customers. That'll work sometimes, right? That'll work the first time on your local machine. The problem is that this service may not be available. It might fail. And so what I want to do is to make sure that I also, if need be, I also retry. Or maybe I retry 10 times. Or maybe I retry when, and I use a back off, right? 10 times duration of seconds 1, right? So there's lots of operators that you can use to rebuild or to retry, I mean. You can also say, oh, well, if something goes wrong, then I want to just return, let's say, an empty string, okay? So that you can handle the exception there, right? You can return an error if you want as well. So exception, whatever. You can do that kind of thing if you want. But this is redundant. There's no need to do that usually, but you know, you can. You can also do a timeout, right? Timeouts are great if you have, if you want to make sure you have the results. So 10 seconds is an eternity, right? Obviously, this is like forever. But this does raise a very interesting question, which is if I have a timeout and I'm calling other microservices, I want to make sure that I get the results back in time. And so here, there's a very interesting pattern here, right? There's a very interesting pattern that we can look at that's actually much better than timeouts, right? So what I want is to get, I call this microservice. This microservice is garbage collecting, or it's down, or something like that. Now I'm in trouble because I need the response from my consumer, from my client. So I need this service I'm calling to hurry up or to fail. So I use a timeout. I say, okay, if you don't finish within, let's say for simple math, 10 seconds, an eternity, right? If you don't finish in 10 seconds, then it's timeout, right? I have to cancel and I'm going to try something else. Well, if it takes 10 seconds to get a result, that means that my total request time is 20 seconds because I try once, it might fail, and it might be I try one more time, okay? But this only gives me 2 chances. It's not going to guarantee the result either, and it takes a long time. What if we could just take 10 seconds, and what if we had 3 chances or 4 chances? Well, a pattern that we can use is called hedging. And hedging is English, and in English it means to diversify the risk, to remove the risk by adding other options. So for example, in the market, in the stock market, you don't put all of your money in the stock market in one stock, right? Because it might go down, right? So you hedge your bet, you hedge your risk by investing in multiple stocks, right? In English, we say, don't put all of your eggs in one basket, right? And that's another way of saying you should hedge your bets, you should hedge. And so what we're doing with hedging is we're saying, look, one of these service instances might be down. 2 might even be down, but it can't be all 3 or 4 of them, right? So we can use the reactive discovery client to ask for some number of distinct individual instances of the service, host 1, host 2, host 3, host 4. And with those results, we can then pick, you know, you might have like 10 instances of the service in your cluster, right? Or whatever, 5 instances, however many replicas, right? You want to pick 2 of the fastest ones, right? You want to pick 2, any 2 of them, and you want to make a call to those services at the same time. So the same call made over the same network twice, right? And so let's say I have a pipeline, just like what I described to you there before, right? Just like what I showed you, right? But now I've got it to 2 different hosts and ports. So I'm calling host 1, I'm calling host 2, and I'll leave this to you. Obviously, this is to do, but this is something like this, right? So you're making a network call. I've got 2 different network calls, but to 2 different hosts and ports. And I want to make sure that I launch both the network calls at the same time, and whichever responds fastest, I will keep this one, and I will cancel the other ones. I'll apply back pressure to the other ones. Well, this is very easy to do in the reactive world, right? Host 1, host 2. Very easy. Oops, this is host 2. So this is going to launch both network calls at the same time. And the fastest one we keep and the other ones we throw away. Very easy pattern in the reactive world. Very hard pattern without reactive APIs, right? So this gives you a very clean, very consistent, very easy way to describe this pattern. And maybe you can avoid the use or reduce the dependency on timeouts. Okay, so here's my client, okay? My client for reactive web. Now, what about the Rsoc endpoint? Well, in order to do that, I'll use this. I'm going to create an Rsoc requester. Now, in Rsoc, there's no such thing as client or service, really, right? What you have, what is this? Oh, that's interesting. Localhost. I think I figured out what they've done to the API. Ah, cool. Okay, that looks right. So in Rsoc, you have a one node and another node, and they might connect. But once they're connected, they are equal. Either one can be the client or the server or both, right? So the client can ask questions, but then the service can ask the client questions, and then then the client becomes the service, and the service becomes the client. So we don't call it client service. We say requester or responder. But either one can be either thing, right? So here's my Rsoc requester. It's a client. We only create one of these in the application. We point it to the host and port up front, right? And then we reuse that for the life of the application. The socket connection stays alive for the entirety of the application, and it's multi-threaded, multiplexed. So now I'll inject this here. I'll say private Rsoc requester, okay? And I'm going to implement this. I'll say this.Rsoc requester.route orders customer ID dot retrieve flux order dot class. Okay, and that's it. That's pretty simple, by the way, right? You could also specify data. You could say like, oh, whatever. You could send a parameter in if you wanted, but I chose to use a URL path variable, and that works, right? And actually, if you notice in this case, it looks kind of like RPC, right? Actually, it is very RPC-like in that respect. So I created a project, Spring project. So it's called Rsoc Spring. There we go. And this project is it's experimental. You can see it says so right there, but it's a project that I created a little while ago. And the idea is you can add it to the class path. You say add enable Rsoc client. You configure your Rsoc connection, and then you can create an Rsoc client interface. It's like feign or retrofit, right? And so you can use this Spring mapping annotations on the interface, and it'll automatically create a client for you. And then you can inject that into your code and use it any way you want, right? So very, very simple. You can even do headers and things like that, okay? Okay, so maybe you'll check that out. But for this, obviously, this is not so bad, right? It's not such a big deal. And with regular Rsoc, you can do bi-directional communication. So now I have HTTP customers and I have orders over Rsoc. And now I want to combine them together. So I want to do some scatter-gather service orchestration. So customer orders, private customer, private list of orders. And what I'm going to do is I'm going to build an aggregate type, right? Orders. Okay, data. Good. So I'm going to take this custom orders type and I'm going to build a new endpoint here that uses those two existing endpoints. So publisher of customer orders, get customer orders. I'm creating kind of a view, aren't I? I'm going to say this dot get customers. That's my stream of customers. And I want to say for each customer, I want to create something to hold the customer and all the orders. That's going to be an aggregate. So I'm going to create a tuple, and I can do this by using the zip operator. And the zip operator takes takes 1, 2, 3, 4, 5, more than one or more parameter, right? 2 or more parameters, right? And each parameter is a reactive stream. So I can say, okay, the parameter on the left is the customer. It's a customer. The parameter on the right will be the order. So I'll say this dot get orders for customer, customer.get ID. I'm going to turn that into a stream, a mono of list of order. So this gives me a publisher of tuple of customer of list of order. Okay. So customer orders tuples. All right. Now, what I want to do is I want to turn each one of those into a custom order. So I'll say map tuple new customer order. And here, tuple get T1 is the customer. Tuple.get T2 is the list. There you go. There's my publisher of custom orders. And that's very easy to express. I'm doing network calls concurrently. It's doing the most efficient thing, so it's doing it at the same time wherever possible. And I'm able to do the scatter-gather kinds of service orchestration very easily. So now I've got my CRM client. Let's go ahead and create a HTTP endpoint, right? Router function server response routes. All right. Okay. Server response.ok.body CRM client.get customer orders .class. Okay. All right, so there is my new endpoint. Let's go ahead and restart this. Okay, so localhost 8082 COs. Whoops. No decoder for client order. See, this is what I get for being special. Oh, builder dot. Okay, wait. Okay, so let's try this again. I tried something new here, friends, and there you go. I should have done this. That looks more reasonable. I'm still used to the old way, which is deprecated now. So RSocket has this concept of message encoding. And there we go. So there's my network calls. I got the customers, and then I've got all the orders for the customers. You see, I'm calling two different services, one RSocket, one HTTP, but they're both just reactive streams. So it's very easy to compose them naturally. Because I've only got one kind of thing, I don't have to worry about a different API to tell my application that I have data coming from Kafka or RabbitMQ or HTTP JSON or a database or WebSockets or service and events. It's not a different API. I don't have to use the Kafka message listener or the RabbitMQ message listener or the JMS message listener or application JSON or SSE emitter, all these different APIs for dealing with all these different things. Now it's just publishers. So my life is easier. I've also got the most efficient version of the code. This is actually less desirable, right? What I have here is n+1. Every customer, I go get all the orders. Sometimes you cannot avoid this. Hopefully, you will build your HTTP endpoints so that maybe they can accept all the customer IDs. So you can say, give me all the orders for all of these customer IDs. That would be better, right? Then you only have 2 network requests. But this is n+1, the least desirable use case, and it's still super fast because it's concurrent, right? We're not doing customer orders, customer orders, customer orders. We're doing customers. We're getting all the customers, and then at the same time, getting all the orders, right? So it's taking very, very, very little time to get all the results. Okay, my friends, we've seen RSocket, we've seen HTTP, we've seen reactive database activity. We've talked about basic reactor types, Project Reactor. We looked at some of the patterns that you can use to build easier service orchestration and composition, supporting scatter-gather kinds of composition here. Do we have any more time?
Well, I think that we can just move to the questions. We have a couple of questions, so if that's okay for you, Josh, or if you want to just spend like 5 more minutes, up to you.
Just want to wrap up here. I just want to say, I think we're just about out of time. It's a shame that we're out of time, though. Maybe we'll do another one someday if you'll let me. We have so much more we could have talked about using reactive Kafka, for example, or reactive RabbitMQ with Spring Cloud Stream to do tell, don't ask style messaging. We could have looked at Spring Cloud Function, which is a serverless API that uses reactive APIs to adapt your API code to serverless platforms like AWS Lambda and Azure Functions and so on, right? There's binders for all that. If we had more time, we could have looked at Spring Security in the reactive context. Spring Security can be used to secure HTTP and RSocket as well. Both support tokens like JWT and username and password like HTTP basic. And so there's a lot of things that we've just begun to look at here, but hopefully you got something out of it. Thank you so much. And I'm happy to take questions now. I appreciate it.
Well, thank you, Josh, for your time and your talk. I'm really glad that we did that on YouTube, so people kind of slow it down and go through it over and over again. But yeah, there are actually a couple of questions here in the chat, so we can maybe go through them.
Yes, please.
The first one. When you were talking about GraalVM, Masood is asking, so in the case of GraalVM, Spring is still noticeably slower than Quarkus and Micronaut. Do you expect things to be much different with the Spring Boot 3?
Yes, yes. We're right now our goal is to support certain kinds of workloads on top of GraalVM. Yes. So that's what we're doing right now. But with Spring Boot 3 and Spring Framework 6, it's meant to be platform-wide, the whole ecosystem, right? We're meant to have support built into Spring itself from the top to bottom. So right now it works most of the time. But yeah, there's some room for improvement. One of the things that there's different things we're working on. One possible avenue that seems really interesting is taking your Java configuration and just turning it into functional configuration behind the scenes for you automatically, and then compiling that. That actually produces faster binaries, for example. So there's opportunities here for a lot of improvements. And remember, a lot of these benefits just come from the improvements in the GraalVM project itself, right? The core of what we had to do, there's some work that we had to do in Spring, but a lot of this work is just making GraalVM smarter about how to deal with more real-world applications. And so once we've worked with them for the last couple of years, the results have gotten much better. Even earlier this year, the time to build an application was 12, 15 minutes. And the result was something that took, 0.2 seconds or something like that now. So now it's down to 0.1 seconds. And, obviously I'm showing you something over Zoom. And so there's something taking CPU, right? So it goes a little bit slower, but it's still very fast. Now, for startup time without GraalVM, the reactive applications typically are, they're typically 1 second, something like that. So I recommend reactive web applications. That said, the GraalVM stuff that we've been done, we also made it work for Hibernate and for servlets and Tomcat and all that. So you can use Spring and GraalVM with non-reactive APIs as well, and that works just fine too. So there's a huge win for a huge category of people, not just the people that are using reactive stuff. I love reactive, but not everybody's using it.
Okay.
Lovely. Yeah, so actually, Sebastian just tweeted today that the 0.9 version, which will be available the beginning of next year, will support many other projects, right, in the portfolio. Then that's great.
I didn't know he tweeted that, but I didn't want to give away his secret. But okay, yes, there you go.
Right. So it's public now, so we can just say it.
Yeah, huge improvements coming, and I've seen some of these numbers. It's crazy. So, we would love your feedback now, though. However, this is the reason I'm showing it to you now, even though it's not GA. As always, I want you to help us figure out what's not working, where you want to see improvements. Right now, we are doing. Right now we have small focused support. So, for example, reactive web support, R2DBC, the Spring Boot actuator, all that stuff works, right? Things like this work. Tomcat, servlets, Hibernate, JDBC, most of that should work, if not all of it, right? I haven't tested every single JDBC driver out there, but the ones we have worked. So big swaths of applications already work out of the box. And there's even documentation on what to do if you encounter a situation where a class doesn't, if you want to make sure that GraalVM knows about a class that's dynamic, there's tools there in Spring GraalVM to support that. But yeah, we'd love your feedback. They're changing new stuff and adding it and making it better every day.
Okay, great. Next question is a short one. It's from Rospergo, and he's asking whether using Java 11 is okay.
Yeah, I mean, yeah, of course. Java 11 is it's better than Java. Many veces mejor que Java, I love it more than Java 8, right? So use Java 11 if you can. It's got var. I love var. I've been using var all throughout my code, I cannot imagine not using it. But I like Java 15, and I cannot wait for Java 17. I'm so excited about Java 17. But right now Java is an amazing language. It's a beautiful, beautiful language. I am a Kotlin Google developer expert, right? So I love Kotlin as well. And so I'm always keeping my eye on these other languages. And it just makes me so happy that Java has really, really grown to be this amazing language. You know, I'm using Java 15. Look at this. Look at this string. This is so cool, right? I can do this in Java. That's not like Kotlin or anything. That just works out of the box with Java 15.
Yeah.
That's amazing. It's amazing. So they're doing great. Java 11 is great. Java 15 is even better. Just don't use Java 8. That's all.
Okay.
Because you know, sir. Once you move from Java 8 to 9, that's where the issues are, right? Because of they waited so long to release it, right? And so as a result, there's all these little small changes that made it harder for people to move. Now, if you're using Spring Boot, you know, if you just upgrade to Spring Boot 2, it just works, right? It automatically works on top of Java 9 or later. And so there's no dependency issues there. You might have dependency issues in your own code, but even that, it's not so bad. You don't have to use modules. And if you're not using modules, then the only real big pain point is the XML libraries, right? Those got moved out of the JDK. But if you're using Spring, we just bring them back in manually. So it's already done for you. There's no reason not to upgrade. It's once you get to Java 9, moving to Java 12, to Java 15 or Java 11 is super easy, super easy. So, you know.
And especially with all the container support and so on. So Java 8 is not doing a great
I don't know.
thing, right? So
Java
it's always good to at least move to Java 11, which is the long time support for Java version. All right, so into the next one. Yeah, so I guess that you have been using command line runner for a long time in your demos, and people are used to the command line runner. Yeah. And someone is asking here, hey, what does defining a bin with return type application ready event mean?
Yeah, well, okay, so that's a great question. Okay, so where's my data here? Do I have something here? Where did I put it? I did it in the orders, right? So order service, here we go. No, I didn't do it there. Where did I do it? In the service? Did I do something in the service? No, I got rid of it there. I get rid of them. There's no more. Okay, well, here. There's several ways to do this, and I think it's just fun to switch around. So you can do bean command line runner, right? Return args, and this will give you public static void main. And then there's bean application runner, return args, okay? And so if you look at the args here, the args are of type application arguments. It's actual thing, right? So application arguments, right? You can use that. And then this one is string array, so string, right? They're both the same thing. And then, you know, the other thing is that we have these events. So you can create an application listener, right? So Spring publishes events when the application context is ready. And this event mechanism, this application listener thing, this is not new, right? This application listener thing has been in Spring since 1.0. This event is fairly new, maybe the last 3 years or something like that. And so you can use this event to listen for when the application context is ready. It's basically the same life cycle as this. Let's try it out, actually. Let's try, okay? So application runner. We'll see which one comes first and comes last. I don't know. It doesn't matter because it's always late enough. So command line runner. And then finally here, okay. So there's this. And then there's also a fourth style, which is you can use event listener. This is an annotation approach to doing the same thing. Okay, so public void listen for application ready event, whatever. And well, first. Okay, good. So let's see. We've got 4 different ways to listen for when the application context is ready. I use this style a lot nowadays because there are other events. Remember earlier I showed you that we have okay, so application runner comes first, command line runner, application listener, and then if you want the very last train in which to do something, you can do it there. But there are other events that you can listen for. These are all basically the same phase. So really, even though this is the order, it doesn't matter, right? They're all the same thing, basically. There's other events that you can listen for. So for example, application, what is it, readiness? Application readiness or availability. There you go, availability. Okay. This is called application. So the other events, application starting, started, prepared, failed, context initialized, environmentally prepared. But there's another one. There's also, is it this one? I don't think it's this one. There's some that you can call for right after the application Kubernetes readiness event has changed, right? And so you can say, I want to get notified right before that event gets published, so I can start doing work. I want to like load the database cache or something, right? I want to do that before Kubernetes puts my application in the load balancer. And so that event is published before the application readiness probe it tells the load balancer to put the service into production. So there's all sorts of great events in Spring. And this annotation style, or this application listener plus the annotation, the interface plus the type, they're both the same in that respect, and they give you access to all the different events, right? So is that answered, I hope?
Sure. Yeah, thank you.
Yeah.
Sergey knows this.
Of course.
Well, next question is also from Masoud, and he's asking whether using our socket for service-to-service communication or request response, if it creates a new connection for every request, or if it creates a connection one and remains open for the whole application life.
One time, it creates it when this application starts up. And that's interesting too, because that means that you can do authentication at 2 different times. You can authenticate when the service and the other service connect for the first time, you can authenticate, or you can authenticate for each transaction, for each request, right? Because you have one socket, one open network connection, right? So that means you don't constantly have to reconnect, and that's much faster. But it also means that you've got one open socket that's shared with all the users in the system. It's a multi-tenant socket, right? Multi-thread, multi-plexed, multi-tenant socket. And so you might want to authenticate. You want to send your credentials, your username and password, or your token, or whatever. You can send it for every single request, or you can send it at the very beginning of the connection when the sockets have been connected. Spring Security supports both.
Okay. He's also asking whether our socket can use HTTP 3.0.
3?
Yeah.
I don't know. I have no idea. You can run RSocket on top of TCP UDP. You can run it on top of Aeron, A-E-R-O-N, and you can run it on top of WebSockets, right? By default, I'm using TCP UDP, but you can try it. I have no idea about HTTP 3. No idea. Didn't even know that was a thing yet.
Right, and the last question, does defining HTTP request handlers in a functional way has any technical advantage over traditional way in a controller using annotations?
Yeah, well, first of all, you don't have to do one or the other. You can do both at the same time in the same application, as long as they're not mapped to the same HTTP URL. So you can't do HTTP GET to /hello, right? You can't do 2 of those. But you can have it in the same, you can have a controller and the functional reactive style in the same code base, no problem. So that's the first thing. Second thing is the functional style it has some advantages, right? Like where's my service? If you go to your service, first of all, this is a builder API. So I can add as many of these as I want. I can do a while loop and so on, right? That's fun. And then second of all, this is so I can talk to a database. I can dynamically add stuff. Second of all, this is kind of verbose, but I can also, remember, I can do this this is just a functional interface. So I can use a method reference there as well. And then third of all, this style has the benefit of all the URLs, all the routes are in one place. Some people don't like that you have to go to different packages to look at all the different controllers to see all the different HTTP endpoints that are exposed in the application, right? Now it's all in one place. And so you can refactor all the URLs just by going to one piece of the code. But technically, technically this style doesn't use any reflection either. So if you care about reflection, this is a little bit a tiny bit faster, but it shouldn't really matter. But we're not telling you to use this. I just like it because it's good for a quick demo, right? I'm just doing a demo. It doesn't. Either one is fine. They're not going away. The old ones are not disappearing. There's no change. There's no plans for anything. It's just use whatever you want. They're both nice. I like this style because it's concise. I'm just doing one HTTP endpoint, so only one HTTP endpoint. So I don't want to create a whole class, a constructor, a private field to store the repository, etc. I just want to have a little lambda and be done. Does that help?
Great. Yeah, so thank you, Josh. I think that we don't have more questions for you today, at least. All right, so thank you for your time. And thank you, everyone, for joining us today with the great Josh. And hope you see you next time.
Likewise. Thank you so much, everybody. Please be safe.
Thank you, Josh.
It's going to be a scary few months, but we'll get through it together, Hopefully we'll all get to see each other maybe at the end of next year. So
hopefully.
Yeah, let's hope so.
How do you say?
All right, so take it easy, Josh.
Is it cuídense?
Cuídense, yes.
Yeah.
Take care of yourself, yeah. So, take care of yourself, my friend.
Yeah, take care, Josh. I'll see you next time.
Bye.
Bye.
Bye. Thank you.